Hello, I am Joshua Manjola, and for my task number one, I will demonstrate the creation of the SCR phase control circuit with varying firing angles from 45 up to 135 degrees. I will be using the Tina Pro simulation software to create the circuit. So here we have a 50K potentiometer, a 220 ohms resistor, a 1N1183 diode, a 2N56T thyristor, a voltage generator, and an oscilloscope to monitor the circuit. So we will connect the circuit to make the SCR phase control. Here we have an SCR phase control circuit. The circuit will now be connected and monitored through this oscilloscope. So we connected the channel 1 to the voltage generator, and the channel 2 will monitor this resistor. So let us now test this circuit by raising the potentiometer percentage setting and monitoring the effects through this oscilloscope. So we can see right now that the firing angle is about 45 degrees. And if we raise this potentiometer setting, we can see that the firing angle decreases. And if we decrease the potentiometer setting, we can see that until a certain percentage, it will it will achieve its maximum firing angle, the closest to the 90-degree angle mark. So here we have it at about 90 degrees. And changing the potentiometer further, we can see that we cannot exceed the 90-degree firing angle. And now in this SCR phase control circuit, we added a capacitor in order to have varying firing angles from 45 degrees up to 135 degrees. So now let us see what happens to the firing angle in the circuit as we change the potentiometer. So we can see that here is already at 90 degrees firing angle, but we can still go further than 90 degrees up to approximately about 135 degrees by adding another element to the SCR phase control circuit, which is the capacitor. It enabled the circuit to be able to reach firing angles more than 90 degrees. And that's it for the task number one. And for my task number two, I will demonstrate the balancing of the Whetstone bridge circuit with an LDR exposed at 650 lux and potentiometer 1 is set at 30% setting. So here is the elements for the given circuit. So we will be connecting the circuit. So here we have a voltmeter to monitor the voltage across the Whetstone bridge, because the principle is that for it to be balanced, it needs to have a voltage of 0 across this coil. So let's set the potentiometer at the 30% setting, the lux level at 650, and there we go. So in order to balance the Whetstone bridge circuit, we can see that as we decrease the value for the potentiometer 2, we can see that the voltage that shows on the voltmeter approaches 0, which means that by decreasing this potentiometer, we are balancing the Whetstone bridge circuit given these settings. So when we increase it, the voltage increases, meaning that we make it less balanced. And so we can see here that in order for the circuit to be balanced, the potentiometer 2 needs to be set at around 14.46% in order for the voltmeter to read the closest to 0 volts. That's it for this task number 2. Thank you for watching.